would like to take a moment and look at this problem. So we have the formula written up at the top. It says the probability of event B given event A equals the probability of event A and event B divided by the probability of event A. Nothing new. Okay, so here's an ice cream example. 70% of your friends like chocolate. 35% like chocolate and strawberry. What percent of those who like chocolate also like strawberry? Now, I'm introducing to you the next type of problems, and I called this at the beginning. I was going to break this into Unit 1A5. This is where we're getting into word problems and also tree diagrams. Okay, so be prepared. 70% of your friends like chocolate. 35% like chocolate and strawberry. What percent of those who like chocolate also like strawberry? Now notice how this question is turned into this expression right here. What percent of those who like chocolate? Like, that's given. Do you agree? They already like chocolate. That's given. That's what we can assume. They like chocolate. What percent of those also like strawberry? So the question is, what's the probability of selecting someone who likes strawberry given that they like chocolate? That's how that would be mathematically phrased. Now, that's equal to, using the formula up above, that would be the probability of or the percent of those that like strawberry and chocolate divided by the number of those that like chocolate. Okay, so they gave us the number of people that like chocolate, that's 70%. We can change that 70% into a decimal by moving the decimal place over 2 places to the left. And they gave us the number of people that like chocolate and strawberry, and that's 35%, so we wrote that as a decimal, 0.35. So we divide 0.35 divided by 0.7, and we find out that 50% of those who like chocolate also like strawberry. Okay, so there's a problem already worked out for you. Now let's look at some of these questions. Number 6, in a school, the probability that a student takes environmental science and geography is 0.25. So let's write this down. Probability of taking, we got environmental science, geography. I'm just going to use an S to mean science, and geography. So S and G is equal to 0.25. That's given. We should write it down. The probability that a student takes environmental science is 72%. So the probability that someone takes science is 0.72. Now, we're talking about the entire school. We're talking about if you were blindfolded and everybody was standing in the gym all mixed up, you were blindfolded, you walk into the gym and you select a student. The probability that student is taking science, environmental science, is 72%. Okay? if you were to do that again, the probability of you selecting someone who is taking both science and geography is 25%. The question is, what's the probability that a student takes geography given that the student is taking environmental science? So it's asking this. What is the probability that the student is taking that a student takes geography and notice the key phrase here. Given that. So we use that symbol, the bar right there after the G, and then we write in S. So what's the probability of selecting a student that is taking geography given that they are also taking science? So there's a formula for this. Do you remember? I mean, how would you write the formula out? The probability of what goes on the top? Let me hear from Amelia.
G and S.
G and S divided by the probability of what?
S.
S. Okay, so now let's fill out the numbers. What numbers go on the top? What numbers go on the bottom? Let me hear from Sierra. 0.25, that's correct. 0.72, that's correct. So now, get your calculators out, figure out what that equals. And let me hear from Brittany. Let's try Minnie. 0.347. So that would round to a 0.3. What? 5. That's correct. Now, do you understand what this says? You got everybody in the school, like just randomly, mixed all throughout the gym. You walk in blindfolded and you pick a student. The probability of picking a student out of the entire gym that is taking both science and geography is 25%. If you were to do that another time, okay, you walk back out. Now, you're blindfolded, you walk back in, and you pick some random student. The probability that student is taking a science class, or environmental science, is 72%. Now, what this question says right here is that, let's suppose everyone in the school is removed from the gym. Everyone. And now, they allow only the people that are taking science, environmental science, they let them into the gym. You see what I'm saying? See, the first two situations, it's looking at everybody in the entire school. And in this last situation, we're only considering the people that are taking what class? Science. So it's the number of people that are taking geography out of the science nerds. Okay? What is the probability of walking into the group of people that are taking science and them also happen to be taking geography? What's that probability? 0.35, 35%. Okay. That's good. Let's do a couple more of these problems because eventually it gets a little bit tricky. Why don't you take a stab at number 9 and then we'll talk about it. In a bag are an economics and a math book. 2 books are chosen at random without replacement. The probability of selecting an economics book and then a math book is 0.42. The probability of selecting economics then math is 0.42. The probability of selecting an economics book on the first draw is 0.62. So what's the probability of selecting math on the second draw, given that the first book was economic? And I think what should be noted here is that these are not the only 2 books in this bag. So, in case that was going to confuse you. So the probability of selecting a math book, given that you select an economics book, that would be the probability of selecting economics, then math, which is 0.42, divided by economics, which is 0.62. And what's that decimal come out to be, Sadie?
0.68.
0.68. Does everybody agree? Yep. Okay, I'm going to leave number 10 for you to do on your own for homework. And let me select a different problem here for us to work on right now. Okay, I'm going to let you do these 3 problems for homework.
What?
Just these 3 here. Math teacher gave her classes 2 tests. Also, a jar contains black and white marbles, and the probability that it is Friday.
Is it number 10 in homework too?
Yep. Number 10 is
From the previous page?
Yeah.
Yeah.
I'm so cold. Is the ones on the other page, you know how we only get...
Okay, so I'm going to give you these for homework to do. And the next problem here that's about a tree diagram, I want to do that together. And I'm going to give you some more problems in the future, especially on the review about tree diagrams. But you need to be able to complete these types of problems. Okay, so Sharon and Lisa share an apartment. Sharon cooks dinner 3 nights out of 10. If Sharon does not cook dinner, then Lisa does. Now watch this, because a lot of people get hung up on tree diagrams, and it's pretty simple. If Sharon does not cook dinner, then Lisa does. If Sharon cooks dinner, the probability that they have pasta is 75%. And if Lisa cooks dinner, the probability they'll have pasta is 12%. So here's what happens. What is the probability that Sharon cooks? You answer that.
It's up one. Yeah.
Sharon cooks 3 nights out of 10. So here's what you can do. You can write it as a fraction. That's probably the best thing to do. Or you can change it to a decimal. So 3 divided by 10 is a decimal that terminates. You can do that. If it's a repeating decimal, don't write the decimal, write the fraction. Okay, now if she's cooking, if Sharon is cooking 3 nights out of 10, then how often is Lisa cooking? 7 nights out of 10, so that's going to be 0.7. Now, if Sharon cooks pasta, it says the probability is that if Sharon cooks, the probability they have pasta is 75%. What's the probability that if Sharon is cooking that they do not have pasta? 0.25. So this right here is given as 0.75, right there. Now, if Lisa is cooking, what's the probability that they have pasta? 0.12. You got to write that in. And so if Lisa's cooking, what's the probability that they do not have pasta? 0.88. Now, I want you to answer these 3 questions. Find the probability that Lisa cooks dinner and they do not have pasta. Lisa and not pasta. The next one is find the probability that they do not have pasta. And lastly, given that they do not have pasta, find the probability that Lisa cooked dinner. Actually, let me rephrase that. Given that they do not have pasta. So that's the given that, not pasta. Given that they do not have pasta, find the probability that Lisa cooked dinners. See how I set that up for you? Now, you're going to use B and C in order to answer letter D. Good luck. Okay, so you wanted to pause the recording there and go ahead and complete this and give it a shot before I show you. All right, so now we're going to go ahead and complete this problem together in case you weren't able to do it on your own. The probability of Lisa cooking dinner and they not having pasta is the probability of Lisa cooking times the probability of them not having pasta, given that Lisa cooks. So that is the probability of Lisa cooking is 0.7 times the probability that them not having pasta would be 0.88. And in your calculator, that comes out to be 0.62. Okay, so to find the probability that they do not have pasta, you have to think about the 2 possible ways they could not have pasta. They could not have pasta if Sharon cooks, or they could not have pasta if Lisa cooks. So in this case, the probability of them not having pasta is actually the probability of Lisa cooking and not having pasta plus the probability of Sharon cooking and them not having pasta. So this is going to be equal to, for Lisa, it's 0.7 times 0.88 plus, for Sharon cooking, it would be 0.3 times 0.25. And so in your calculators, you can figure out what that comes out to be. And I have 0.69. So our final question is, given that they do not have pasta, find the probability that Lisa cooked dinner. So the probability that Lisa cooked dinner, given that they do not have pasta, is the answer from letter B. It's the probability of Lisa cooking dinner and not having pasta divided by the probability of either of them cooking dinner and not having pasta. And so the answer is 0.62 from the answer to letter B divided by 0.69, the answer from letter C. And so you put that in your calculator. And you come up with 0.898, which rounds to 0.90. So 90% of the time, if they do not have pasta, Lisa cooked dinner.